load. Yeah, so and it will have to load, I have heavy applications on it. Okay, so immediately it's downloading, should join with my system and I'll be able to share my screen. So before that time, somebody was talking about the assignment I gave the other time. So is Joy around, and people that raised up their hands the day before yesterday? Okay, so now the assignment was given the first day that we met, right? Yeah, Joy is around. Okay. So I don't know if there's any other person that, yeah, if there's any other person that have done the assignment, you are going to love it because it's research and you're going to discover a lot of stuff. I wish I can give more research like that I would have time to oversee. But I'm going to be sharing immediately after today's class. I'm going to be sharing few links with us that will help us, take it from where I stop. We can just take it on. There are different, resources, PDF, videos, where you can, continue from there. So, okay, so I don't know if any other person is here that was here on the first day. Kindly raise up your hand. Let me see. Apart from Joy, I know Joy was here. There's any other person that was here? Okay, Chinedu was here. Okay. Okay, so I will start with Joy. So, Joy, what have you discovered? What did you learn from what you researched? So, Joy, you can unmute yourself and speak to us. I'm waiting. Is Joy still on this call?
Yes, sir. She's still on the call. Oh, I was actually searching for my jotter where I jotted down something, but I'll just say what I can remember because I can't find it now. It's not that close. So I start. It was when you're teaching. That's the last class. I discovered that I start for probably the wrong thing, but I researched about Trojan horses because when I researched about the different what's the name? The different thing it brought out a lot, and he said we should just pick one of our choice. So I searched about the Trojan. Sorry, saying something.
No, go ahead. Go ahead.
Okay, so I researched about the Trojan horse, and what I got to find out about it is that they they impute their illegal source into something that is legal. Then it functions only when somebody uses the site or the application. It cannot just function. So immediately the person opens the application or the site to do whatever he or she wants to do, then the way that the hacker program it, like the things the hacker wants to find out and get, everything will be like, let's say, downloaded on the hacker's files, or the person will just get what he or she has asked for or is looking for. So I learned about that one, and I read about a few things, just I can't really remember because I can't find my jotter now. So
okay.
yeah. Yeah. Thank you.
Yeah, you're welcome. Yeah, you're welcome. That's interesting. At least you learned a few stuff that are very interesting. Okay, so Chinedu, can we have you?
Okay, good evening.
Good evening.
Okay, you said we should make a research about hackers, and you said there are 4 outlines you asked us to research about a particular a particular activity done by an hacker. We should get the kind of attack launched, the tools used for the attack, the system or technology of the organization attacked, and impact of the attack.
Right.
Number one, in terms of, there's a particular guy, the Jester, that's his name. He calls himself a hacktivist. That is a grey hat hacker activist. He also calls himself a computer vigilante. So he launched a particular attack on jihadist websites. There's a particular jihadist website that was, I think, in 2001 or so. So the kind of attack launched is denial of service. That means he tried to deny the jihadists from communicating with each other, because the guy is an American, is against jihadists and I think homosexuals or something like that. Like anything that has to do with American government, what they like are against. You know, the American government, they're against these terrorists, so he's also against them also. But he calls himself a grey hat hackist. So the system, like I said, the kind of attack launch is denial of service attack. Then the tool he's used is there's a particular app he developed himself. It is called Xstar. That is XERXEX. He claimed that he developed that application himself. Then the system he attacked is the websites of the Taliban websites. And what is the impact of this attack? He disrupted online communication between jihadists. So he hacked their website, so they were not able to communicate to execute their activities. There are a couple of other attacks he did also, but this is a particular one I read as regarded. So thank you very much.
That was great and incredible. That was awesome. You know, it's always interesting when you actually identify and research about some of these things. It gets you informed and gives you like insight into how these people operate. Beyond just reading textbooks about cybersecurity or watching videos about it. So that was great one. And anybody that is coming into this this field that is passionate will always go for this kind of information so that they can be able to foster communication when they are amidst other cybersecurity experts or other cybersecurity professionals. So I'm going to be pasting I don't know, my system is acting. I'm going to be pasting a link now, and then also I'm going to be pasting 2 links for 2 different cybersecurity communities. And I would want everybody on this call to join those communities. When you join those communities, you will learn from the experts, because the community contains both beginners, professionals, and experts, and even leaders in the industry. Now, the first one is the area of ACA-Haze. The second one is Young CISO Network, that's Young Chief Information Security Officer Network, and that one has a lot of containing a lot of cyber leaders that you would have interaction with. And these 2 communities are running internship. I think Young CISO Network is currently running an internship on a cohort basis, like they have streams, so there are current streams happening right now. And if you can join, I think they'll be having a physical meeting come 30th of this month. And if you can join, it's a good one. So you'll be able to join the next cohort, internship cohort. You learn a lot from them. And I think the internship is like 33 months or something. Other than this, just 3 days. We've not even covered the most basic fundamental, because we were just going into networking that we had to cut it off the last time we were together. And networking, even the fundamental of networking is wide, and it's not something we can even cover today. Even so, it will just be like an introductory aspect of what networking is and we're talking about today. Okay, I don't know, my system is acting, so I might just speak like this, and just introduce us to what networking is, so field network devices, and the OSI model, that is open system interconnection model, the 7 layers of OSI model, and how computers communicate on a network. So I can just give you like that introduction, and let's see how we move from there. just 1 hour. So yeah, so I will just go ahead and paste. Then I will entertain questions also. Sorry. Let's go ahead and paste. Okay. Hope we can still hear me, right? Yeah, the link. I'm going to drop the link in the chat box. Hope we can see. Yeah, hope we can still hear me.
Yeah, we are hearing you, sir.
Yeah, so I'm pasting the link now to the drive. It's a Google Drive. There is a whole lot of resources there. You know that, and the drive is starting a career in cybersecurity. It means everything there will show you like strategies and how you should go about it, even without anybody directing you. That's for the Google Drive. So I'm going to be pasting for the two communities, the Young CISO Network, and let me just copy them and bring the Young CISO Network and this other one. That is AKA A. Yeah, AKA is. Let me copy. AKA is. Please immediately you can join. You know, you can just join and register immediately, or if you want, you can wait. Just advise that you join immediately. Okay. Just give me a few seconds. This is loading. Okay, it has loaded. So let me copy. And then okay, let me just copy the link and just paste. Yeah. Okay. Okay, so this is the link to AKA is community. AKA is community. So let me copy for the Young CISO Network. So for the Young CISO Network, I'm part of the core team who is in charge of the internship, and so you might be seeing my break light on the Discord channel once in a while. Okay. Give me, just trying to copy those things. Okay. Young CISO Network. Okay. Okay, so currently there is a shortage of skill gap in cybersecurity. We have about 3.5 million on field cybersecurity job around the world, like across the globe. So and we need more people like you who are passionate to come into cybersecurity. So I'm saying this to encourage you that there are jobs, but it's just that people are lacking the skill to fill those jobs. You get. So if you are coming in and you are very skillful, you are passionate, you know what you're doing, it will be very easy for you to get a job. Now, cybersecurity is not like digital marketing that you can do like 4 days boot camp and then you will start. That does not require too much. You can start on your own and start doing ads on Facebook, ads on Google AdSense and the rest. Cybersecurity is not like that, because cybersecurity is an industry. It's an industry, and that industry is wide. Like, it is wide. We have more than 100,000, job titles or job specification or specialization in cybersecurity. So you can see somebody saying they are threat intelligence analysts. You can see another person saying they are open source intelligence analysts. They are all after intelligence, but it's just that the kind of intelligence they look at, they go after is different, but they are all under intelligence domain. So you can have like a 30, titles under one domain, 50 titles, and these people are, going after the same goal, but the strategies are different, So, and because of that, it is not easy to say, okay, just the way you learn in 1 week digital marketing or in 3 days and start doing AdSense, start doing advertisements and turning ads to money. It is not like that, because no company will want to commit the network of their organization or even the health of their organization's infrastructure into the hands of somebody that learned the skill within 1 week. No organization will do that, So yeah, okay. So just try and join these communities, and let me see if I can just do like introduction to networking. I don't know why doing it like. Okay, so let's see if we can just quickly cover something small. Introduction to networking. Oh, okay. Let me switch. I think my system is back. Let's see. I'll be able to switch. Okay, it's working. Okay, so I'm back on my system. So let me see if I should be able to open the last slide we used and just quickly cover the networking aspects, and then I will entertain questions. Okay, so yeah, as I'm opening, let me just start. You know what normal when we say networking, without adding the computer now, networking means the connection or interconnection of a group of people or a group of things. When things network, when they interconnect, that is networking. I know you would have heard of multi-level marketing of networking or multi-level networking, where you bring somebody and that person will register under you, then they will buy a point value product. I know some of us engage in some of these things, so that is like a network of things interconnecting together. So now bringing it to the level of computers. When we say computer networks, we're talking about the interconnection of computing devices. Not just computer alone. It can be a phone and a computer. It can be a phone and a phone. It can be a computer and a phone. It can be a printer and a computer. And we interface with computer networking every day. For example, I am using my system and my headset, which is like my headphone, is connected to the system. That is a peer-to-peer networking, because I'm connecting my headset to my system. That's a peer-to-peer. It means it's not far from each other, and it is just limited to one device and another device, not more than 2 devices. Okay, so we interface with networking every. I'm trying to open just give me a few. So now we interface with computer networks every day, because even some of us in our house, we have a printer and we connect that printer to our system. We connect the printer to our system, and we use it to print whatever we want. That is a form of network. Then some of us that might have worked, or maybe even in schools, you see schools in school classrooms where they do practicals for secondary school, even higher institution. You see a network of computers. You see computers, array of computer networked together to share resources. So the purpose of computer network or computer networking, is to share resources among the devices that are connected together, to share resources.
among the devices that are connected together. So that is the goal of computer networking. So it means that you are connecting one device to another for the purpose of sharing a resource from both ends, from this device to the other and from the other device to this other device. So it means if there's no means of connecting one device to another device, a sharing of resources will not take place. You get that? Sharing of resources will not take place. Okay, so that is the major goal of computer network. And then we have different types of network topology. When we mean topology now, when we say topology, we are talking about the physical arrangement of how network is or how network looks like. The physical arrangement. We have the bus topology. That is, that one is rampant in the 90s and the 80s, where you see computer being networked like the way a bus is, as long as that, like you see one cable, connecting like 5-6 computers together, like a bus. The way bus is long like that, with no break in between. That is a bus topology. That is, you are not there's no cable, giving another direction to network another device somewhere that is not close to where you are, or where the first device is. I don't know if you get that. That is a bus topology. I don't know why this thing is not opening. Okay, let me just continue. I'm just saying all this from my head. Okay, then there is ring topology, where the way ring is, it is connected cyclically, not like a bus. No, now if we are talking about bus topology now, at the end of each, it means that at that end you can join another device at each end, because it is bus. It goes straight down like a bus. But when we talk about ring topology, it is cyclical. It means that they are all joined together in a cycle. They are all joined together in a cycle, and there is no way of joining another device except you disconnect one device from the cycle and then join another device and then close the cycle back. That is like a ring network, a ring computer network. It means you are joining the devices together cyclically, and there is no way by which we bring in a new device if you do not disconnect the device and then connect this new device that is coming in and then close back the cycle. That is ring topology. There is star topology. And star topology is very rampant nowadays, where you have like one network device joining different devices, joining different hosts. Like, for example, we have a switch at the middle, and then we now have different other devices that are joined together, into one switch. So a switch can have, now a switch is a network device that joins a different hosts to share the same resources. A switch is a network device that joins different hosts. Now, when I say host, a host can be a laptop, it can be a desktop, it can be a phone. Any device that has an IP address is a host. I'm going deeper, right? I've mentioned IP address, then I need to explain what IP address is. Okay, so for example, you have a home, you have a house, right? And your house has an address. So it means if a dispatch, if a dispatch rider is going to send something to you from Jumia, they need your address to get across to you. So a host is a device that has an IP address. So IP address now is called Internet Protocol Address. A protocol means a means of communication. Protocol can be any type of protocol. But now we are joining internet to it. It means IP means Internet Protocol. That is a mechanism of communication over the internet. So now that mechanism of communication now has a number attached to it to identify individual devices on a network. So when we say host, host is any device on the network that has an IP address that can, be identified with a kind of address that uniquely, identify that device on the network. So it means if you are sending like a data from device A to device B, and there are like 4 devices on the same net on that network, maybe we have one switch, that connects like 6 devices, like 6 laptops and 1 printer together. Now, all these devices, printer, the laptops and the desktops, we have different IP addresses to identify them from each other. So if device A is sending a data to device E on that same network, device A will send the data across to the IP address of device E, so that when the data is being routed, it will be routed to device E without branching device C. Okay, so I'm going deeper, but let's just stop there. I'm just trying to explain what IP address, because I've mentioned IP address. Some of them you might have heard of it, but that is the workability and the functionality. Okay, so I'm talking about star topology, right? Okay, so with that switch device in the middle, you can connect different. So it means that if that switch has like 10 ports, a port is like it's like where you can connect a device, like a hole that can accommodate the cable that is coming from another device. That's a port. We have charging ports, right, where you can connect your cable, your charger to. That is just like that. So when you are connecting a cable from a device, you are connecting it to a port on the switch. So now we can have like 10 ports on a switch. So it means with that 10 ports, we can connect 10 devices to that switch, and those devices will be able to share resources. Okay, my slide is up, so let's see. Okay, so these are the types we have. We have mesh. So we have mesh topology. That one is very sophisticated. It's not like the rest of others that are very simple. Okay, so those are topology, the physical arrangement of network, of computer network. Okay, so let me see if I can share my screen. So that is just the basis. Okay, yeah, of topology. And then there are different concepts you need to also know about. I've mentioned IP address as it comes to computer network. I've mentioned IP address. I've mentioned switches. A switch is a network device. Okay, there's router. A router is a network device. A router is a device that connects. Okay, now before I go to network devices, I will have to explain types of networks. We have local area network. What I explained the other time is topology, that is the physical arrangement of computer network. Now this is types of networks. So we have LAN, local area network. Now, local area network is the connection of different computing devices within a building, like your home, your small office, and the rest. That's a local. When we say something is local, like it is within a building, within a confinement, within a confined area. It won't go beyond that building. That is local area network. Then we have metropolitan area network. That is MAN. The first one is LAN. We have MAN. Now, MAN is connection of buildings together, connection of networks between buildings. Like you have in like maybe you have in your office, you have the department for sales, you have the department for marketing, and then those departments are in different buildings. you connect them together. That's Metropolitan. You connect different buildings together. Then we have wide area network. I'm just trying to explain in a layman understanding so that you understand better. If I want to use cybersecurity terminology, I will have to be breaking down some stuffs again. I don't want to do that. Okay. Okay, so let me share my screen. Yes, D-links. Yes, Tiwa, you're correct. Tiwa, you're correct. Okay, let me share my screen. What? It's showing you. Sincerely, you would cybersecurity is interesting. You would enjoy it because you'll be learning so many things. I don't know why this is not showing. Okay, let me share the whole screen. That is what it wants. Okay. Okay, can we see my screen? Has it come up?
Yes, it has.
Oh, thank you. Okay, so yeah, I was talking about WAN, right? I've moved from MAN. You see here, they included just local area network and wide area network because MAN sometimes is between these two, then wide area network is when you are connecting devices across cities, across cities, across nations, like the internet. Internet means internetwork. That is different networks connecting together, internetwork, the interconnection of different networks around the world. So a typical example of wide area network is the internet, connecting networks. So it means that you will have different LANs and different MANs connecting together to form a wide area network. Then there's campus area network, CAN, right? That's within like a school, connecting faculties together is still like, a bit close to MAN, right? There are a lot of them like that, different, there's SD-WAN, and the rest, those are deeper stuffs, right? Okay, so yeah, those are the types of network that we have. Then here they were saying what are the compromises that comes to network, where are the compromise, where do people compromise network, computer network? Number one is design. So it means that if you are designing a network for an organization that has an headquarter and has annexes, there is a way the architecture of that network design should look like, So if you do not design it very well as what will fit that kind of setting, it means that it will be very easy to compromise that network. That's what they are saying here. Design issue. So you see network engineers are very good when it comes to designing a network for any kind of organization, any kind of, because design is very key. And even if there is a mistake in design, the communication between the devices that are being connected together will be compromised. It means that there won't be smooth communication, number one, and there will be problem, troubleshooting any issue that arises in that network because the design is there is a misconfiguration. There is no, the design is not well structured. Then the construction, where you are supposed to put router, you are putting switch. You will have collision. There will be resources or data jamming each other and the rest of them like that. You don't need to know too deep. You just need to know how the networking works, and which is what we're talking about now. Okay, and then the use of a network. You cannot use a LAN to do the work of a WAN. Right? You cannot use a MAN to do the work of a LAN, right? So it is, if you are using a MAN to do the work of a LAN, it is either you overwhelm the devices on that network with loads of data and then crashes your software or your firmware, it won't affect the physical computer, the physical device. It only affects the firmware, which is like the underlying software that makes the computer works, you know. Yeah. So management, maintenance, operation of the network infrastructure and software and policies, this can be compromised. You know, misconfiguration. You are not configuring the router well, the way you are supposed to configure it, or maybe while you are configuring, you are not putting your mind, and where you are supposed to encrypt the password that, you know, helps to authenticate into, you know, helps to log in into the router. You do not encrypt it. You left it like that, you know, and you know. Any capture of traffic that goes over that router can, you know, can be in plain text. So it means that data sent will be in plain text. Even, you know, when you enter your password, it will be in plain text. So anybody that sniffs the network traffic will be able to see the password in plain text. These are compromises, you know, that happens when it comes to networking. Okay. Yeah, enables devices. We've said that essential function is service providers, businesses, and consumers. You know, individuals use this network for whatever they want to use it for. Businesses use it to thrive, to share resources amidst their employees, and use it to send out, you know, memos, send out emails, and the rest of them. Service providers, you know, network like Zane, like Glow, like SpectraNet, they are service providers. Without networking, they cannot sell because there's nothing to sell, right? They are selling network, okay? Then it facilitates telephone calls. Networking facilitates telephone calls. You know, it facilitates text messages, streaming, Internet of Things, and the rest like that. Okay, so yeah, I explained this the other time. I think they explained it here also. I said within like a building in a confined area that does not go beyond that confinement. Okay, a local area network is a group of computers and peripheral devices that share a common communication line or wire links. These are English, right? A server within a distinct geographical area, like in a building, and it doesn't go beyond that. That networking and communication does not go beyond that building. You know, a local area network may serve a few, 2 or 3 users in a home office. I mentioned home, I mentioned office, you know, thousands of users in a corporate central office, okay, in just one office. Yeah, a wide area network is a geographical distributed private telecommunication network. Interconnects. You know, I mentioned interconnects the other time. Multiple local area networks. I mentioned that the other time. So in an enterprise or business, a WAN may consist of connections to a company headquarters. You know, I mentioned that the other time, that you might have a branch, you might have an headquarters and want to connect to your branches, annexes. You know, that's WAN. Branch offices, co-located, co-location facilities, and the rest. Okay, that's why you see clusters of different, you know, networks, local area networks connecting together. That's one. But you see here in LAN, there is just one, you know, one like 3 systems connected together with one server. Okay. Okay, wired networking. Wired networking. So I would not say this is a type. I would say these are groups or category of networks. So one man, you know, LAN are types of network. Okay, you know, English sometimes can be very, very confusing. Okay, so this can be like categories of network. We have wired network and we have wireless networking. Okay, so wired networking requires the use of physical medium to transport between nodes. Nodes are like one point of connection to another point of connection. That's nodes. Okay, copper-based Ethernet cabling. Like I have a router in my house and I use LAN cable, Ethernet cable that connects the port from the port from the router to my system. That is wired networking. Popular deal for the low cost and durability. It is very durable. You can use it for a long time. That is, if nobody cuts the wire or something is intact, you can use it for a long time, and it's not costly. How much are they selling RJ45? You know, and Internet cable and the rest. So it's not costly. Okay, optical fiber. These one are very expensive because these are the, you know, the transport data over greater distance and at faster speeds. These are the ones that you see that they use to connect different masts, apart from using electromagnetic wave. They use fiber optics, so that one can go underground. It is very heavy and very powerful. Okay, we have wireless networking, uses of radio waves, electromagnetic waves to transport data over the air, microwave, you see, satellite, cellular, Bluetooth, all those ones, wireless LAN, like you have a MiFi, a Wi-Fi router that has wireless LAN capability. They are used today, and currently I'm using my phone as an hotspot, to connect my system. So that is wireless networking. These are things we face. Oh, so excuse me. Sorry about that. Okay. So these are the things that we see every day. So physical network infrastructure. Wow. Physical network infrastructure, we have switches, we have routers. I told you what switch is. Okay, they didn't include switch in this LAN. This is just a normal, this is a ring connection, this is a ring topology. Okay, so switches connect different hosts to share resources, different hosts, while routers connect one or more LAN together. So it means when you have, for example, let's say this LAN now, this LAN diagram, this is one. Oh, let me use this one. So let's say that this is one LAN, this is one LAN, this is one LAN. Let's say they are not using ring topology as they demonstrated here, and they want to connect this LAN to this LAN. So they can use a router to connect this LAN to this LAN. That's why we say router is a network device that connects two or more LANs together. You get, so yeah. Okay, so wireless access points, just like your wireless router, your MiFi, those are wireless access points. Firmware that operates the above, there are firmwares that operate some of this, all these devices. We have protocols. Protocols are standard set of rules that determines how a system communicates. I mentioned that the other time, that a way of communication. A protocol is a way of communication. So like a set of rules, the standard of communicating on networks, across networks. And we have two different systems that use, the same protocol, can communicate and understand each other despite their differences. Like how two people can communicate and understand each other by using the same language. So for example, your computer can communicate with a server by using the HTTP or HTTPS, that's hypertext protocol, HTTP. Then the S there is secured, right? Hypertext transfer protocol, right? So it means any client system that connects to a web server over that kind of protocol will be able to understand each other. And that is why you browse from your system using a browser. And then, as you browse, you receive resources from the server, because the server understands the protocol by which you are browsing, which is the HTTP or HTTPS, right? So that's an example. And we have these different protocols. Example is voice over IP. This is a protocol. It can transport IP telephoning traffic to any endpoint that supports the protocol. So we have IP phone, internet protocol phone, that has voice over IP protocol. So it means it can communicate with another IP phone that has the same, or another device that has the same protocol like that. HTTP provides a common way for browsers to display web pages. I just said that now. The Internet Protocol Suite, TCP/IP, is a family of protocols responsible for transferring data and services over an IP-based network. You see, so those are protocols here. So I think that is the end for networking basics here. But even the fundamental is deeper than this. Okay, so but let's just stop here. There is OSI model, that is the way computer communicates over the network. OSI model. We have layer 1 to layer 7. We have the physical layer, we have the data link layer, we have the network layer, we have the transport layer, we have the session layer, we have the presentation layer, and the application layer. It is the application layer that you, a user, interact with, the software application that you interact with, but you do not see what is going on behind the scene. And all those things that are going on is what they explain with layer 6 to layer 1. Of course, at the layer 1, you see the router, you see the physical, devices and the cable, which is at the layer 1, the physical layer, the wiring, the cabling and the rest. But from data link layer to the presentation layer, it is out of view for human eyes. So it is what goes behind, the scene in the networking configuration and the rest. So, and the reason why you need to understand this is because, oh, no, the slide is, I'm done with the slide. I'm just explaining now. See why I'm done with the slide. You see, this is the end of the slide here. So this one I'm talking about now is not included here. I'm just saying it from my heart, right? So the OSI layer like that shows how, okay, you know what I would do? Let me go to my browser. Let me show you what it is, what it is, right? Let me show you what it is. OSI layer, okay, so that you at least you see it. OSI layer explained with example, yeah. Let's see, this should give us like a diagram, right? You see, these are interesting stuff that when you know, the confidence is there. So they ask you, do you know about computer networking? You say yes. Oh yeah, explain. What is? This one did not have. I want the one that has the diagram. Let's see this. This should have. Let's see. This should have. Let me see. Don't mind me. I opened a lot of tabs, right? Don't mind me. Okay, so. Okay, so let's aha. I think this explains it better. Aha, this explains it better. Yeah, you can see this, right? Let me see. Open image in the tab. Let's see. Yeah. Hope we can all see this, right? Yes. Okay. Yeah. Okay. So yeah. Now this is it. This is what I've been saying all this while. The physical layer, you see, to transport bits over a medium, the coax, the fiber, the wireless, the hubs, the repeater, the router, you see physically. This is the data link. So this is where the hardware lower layer is. The hardware lower layer. So you see the data link. So it means that when you send something from your system, that thing you send passes through from application, you see, software upper layer. This is where human being operates to allow access to network resources. This is where you operate. This is where your browser is. This is where your client system, whatever you are using to connect to the internet or to the network is. So when you send the data, you see sender. You see this? You see this? When you send, you see this side. When you send the data, you are sending directly down the link, down the step to the physical device. So it is here that we now pick what you sent, the data. From here it would have been transformed to different formats that the network, the computer will understand. It will not send it like the normal picture you send. It will transform it to code, zeros and ones, and it will come down, straight down as a sender like this. And then this place will receive it, right? And send it to where you have sent it to. And then when it is coming back, this place will receive it again. This physical layer will receive it again and send it back. You see this arrow goes back to you, the user. So when you go to your browser and say www.facebook.com, a lot is happening that you don't know. You see that the page comes up very quickly, but there are lots of things happening. And that is what they're trying to explain here, what was happening. So this translates and encrypts the data, compress it, brings it here, terminates sessions and establish sessions, brings it to the transport layer, provide reliable process to process messages delivered, moves the packet from sources to destination, like that. So that is about, you know, the OSI model and the layer. There are different devices. For example, this physical layer, there is the wires and everything, like cabling. Then here there is your switch. Here there is hub, there is repeater. Here there is switches. Your switch is at the data link layer. Then at the network layer, we have the router, right? We have the router. At the transport layer, we have the load balancer and the firewall. These are the devices in each of these these layers. So, but for now, you don't need to go deeper into that. So we have network engineers that understand this deeply. You are a cybersecurity, you just need to understand it to like an intermediate extent. You don't need to go deeper because what you are protecting is a network. Let me stop my screen and then we can entertain questions. So you are protecting a network. Everything you want to do is protecting a network. Whether you say you are protecting a computer will still connect to something. So you are protecting both that computer and something that is connected to. You get, so you are protecting a network. You grab. So that is why it is very important you understand how networking works, right? Okay, so I will just end it here and entertain a few questions, and then we call it a day. I've given us the links that we need. Then you can reach me on LinkedIn if you still have any clarity or confirmation. Okay, so yeah, let's entertain questions. You can unmute yourself and let's hear from you. Any questions? Please, before you unmute yourself, raise up your hand, then I'll call you. Okay. I'm waiting, please. Within 5-10 minutes, we should be done. They didn't refer to ISP as network. They said ISP, internet service providers, also rely on network. Without network, there is no business for them because they are selling data, and the data you are using, you will use it over a network. See why? I hope you understand. They are not referred to as a network. They said what they are trying to say is they rely on networks, just like we have other businesses, like organizations relying on network to go about their day-to-day business, and consumers like I and you rely on network to make calls, to do stuff in our homes. Okay. Any other question, please? Okay, so if there's no question, I'll be calling it a day here. So far, we don't want to ask questions, right? So I'll be calling it a day here, and you can move on from the resources I've shared.
Hey, sorry, Sal, please. There's the link you sent to us, the first link. I don't know, when I clicked on my Chrome, the thing took me to a document, my Google Drive.
Yeah, you will feel it. Like, oh, which one? The first link? Is it the first link?
Yes, the first one.
Yes, a Google Drive. What happened?
Okay, I was thinking maybe a community that will join or something.
The first link is a link to resources, a Google Drive where there are resources. The second and the third link leads you to a community to join.
Oh, okay.
There are three links I shared now.
Yes, sir.
Okay, you said, okay, Tiwa, people usually refer to them as network. Anybody can call anything. They are not network. Of course, they provide data, for you to use on the network. So they call them network. You know how people do now, based on general, people can call anything. It doesn't mean that that's what they are, right? So yeah, okay. Please, anybody that has the link should share it, please. Thank you, because I shared it on my phone and I'm on the system now.
Okay, sir, please, one more question. Please, sir, while researching on that Trojan, I came across something I don't really understand. They said Trojans are not able to self-replicate. Well,
Yeah,
unlike
that
computer
means,
viruses and the worms.
yeah, yeah.
mean?
What they mean is that if you do not actually download a software that contains a Trojan will not download on your system by themselves, and they will not attach themselves to any other file apart from the file that they have infected. I don't know if you get that.
Oh,
so it means,
okay.
yeah, it means if you have a Trojan on your system, and you impute a USB to your system, if that Trojan has not been activated, it's still within a file that you downloaded, it has not been activated, because most of the time, or it's still within a software that you downloaded, you have not installed the software. It will not do anything until you install. When you install the software, it then initiates. That's when it affects your system. Do you get that now? So they are not self-replicated like virus that immediately enters your system, it begins to attach to files, begins to attach to other stuff. That's what they mean.
Okay. Yes, sir, I understand now. Thank you.
Thank you, Tiwa, for those. So those are the links. Okay, so thank you very much. If you still have any other question, you can reach me on LinkedIn, and I hope you develop interest in this field.
Hey,
And,
sir, please, your name on LinkedIn.
okay, let me type my name here. I will type my name now. That's my name on LinkedIn. Segun Ebenezer Olaniyan. So yeah, thank you very much and have a nice day. Thank you.